Good day everyone. In this video, I will share my overall reflection and learning from this control engineering subject, including the laboratory experiments and reaction videos that we completed throughout the course. So at the beginning of the subject, I honestly thought that control engineering was mostly about solving equations and analyzing block diagrams. But as I continued learning through lectures, MATLAB activities, laboratory experiments, and video discussions, I realized that control engineering is actually about designing system that can behave properly, safely, and efficiently in real-life situations. So one of the biggest thing I learned is the importance of feedback system. I learned that the difference between open loop and closed loop systems. In an open loop system, the output does not affect the input, while in a closed loop system, feedback is used to compare the actual output with the desired output. So this feedback allows the system to automatically correct errors and improve performance. I also realized that feedback is everywhere, from automatic temperature control to robotics, vehicles, communication systems, and even satellite. So another important topic I learned is system stability. I understand the difference between stable, unstable, and marginally stable systems. So a stable system returns to equilibrium after disturbance, while an unstable system becomes unpredictable or unsafe. Through pole zero analysis and root locus plots, I learned how the location of poles affects the behavior of a system. If poles are located in the left half of the complex plane, the system becomes stable. This topic helped me understand the mathematical analysis directly affect real-world system safety and reliability. I also learned how to use tools such as MATLAB, Simulink, and SISU tool. At first, these tools were difficult to understand, especially when connecting mathematical concepts to graphical outputs. But through practice, I learned how simulation help engineers test and verify system before actual implementation. MATLAB made it easier to visualize impulse responses, step responses, root locus plots, and controller performance. I also realized that simulation tools are essentials because they reduce errors, save time, and improve system design. One of the most interesting topic for me was the design of PI, PD, and a PID controller. I learned that the proportional term improves response speed, the integral terms remove steady state error, and the derivative term helps reduce overshoot and oscillations. I also learned that the controller design is not just about choosing values randomly. Engineers must carefully tune the controller depending on the required performance, specification like settling time, overshoot, and stability. So, the reaction videos also help me understand how control systems are used in real engineering applications. For example, the video about designing a real control system for an Earth orbiting satellite showed me that engineering is not only about theory. Engineers must also consider real-world problems, environmental conditions, testing, verification, and system limitation. I learned that actual engineering design is a continuous process of modeling, testing, adjusting, and improving. So another lesson I gained is that engineering requires both technical knowledge and critical thinking. Sometimes the mathematical solution may work in theory but fail in actual implementation because of disturbance, noise, or hardware limitations. That is why testing, verification, and simulation are very important before applying system in the real world. Throughout this subject, I also experienced many challenges. Some topics were difficult at first, especially understanding root locus, interpreting graphs, and connecting equations with physical behavior. But through repeated practice and experiments, I slowly developed a better understanding. So these challenges taught me patience and the importance of continuous learning. Overall, this subject helped me realize that control engineering plays a very important role in modern technology. It combines mathematics, programming, simulation, analysis, and design to create systems that are stable, efficient, and reliable. As a future engineer, I believe the knowledge and skills I gain from this course will help me in designing better systems and solving real-world engineering problems. Thank you guys.